All right, so we're going to look at 7.3, adding and subtracting rational expressions. This is usually with monomial denominators. We're going to look at a harder one with trinomial denominators, but it works the same way. So this is a question that'll look like, these are the basic ones, where you're going to have two terms that are added or subtracted together. But as you could tell right away, they don't have common denominators. You can't add them together. This is just like basic fraction questions you used to get when you couldn't add these two together. So what you did was you multiplied both of them by each other's denominator to make it something like this, and then you were able to add them together. So this would become something like 11 over 12. We're going to do the exact same thing, except we're going to do it with exponents, or not with exponents, with variables. So let's close the space. When I look at these two, they don't have the same denominator. I'm going to multiply over here by 4x over 4x. This is going to give me an equivalent term because 4x over 4x is equal to 1. So I'm just multiplying by 1, so I'm not changing anything. On this side, I'm going to multiply by x plus 1 over x plus 1. You're allowed to do this. You're allowed to multiply by binomial. That's okay. So when we do the multiplication, I get 3x plus 3 over 4x squared plus 4x minus, and over here, the denominator is 4x squared plus 4x. The numerator is going to be 8x plus 4x squared. So as we notice, the denominators are both the same. So what I'm going to do is I'm going to combine these into one big rational expression. I have to be careful when I'm doing subtraction though, because that negative applies to everything inside this divisor. So it's going to become minus 8x minus 4x squared. These two terms are going to stay the same, 3x plus 3. Now I'm going to collect any like terms that I have. So I ended up getting, what's that? Negative 4x squared minus 5x plus 3 divided by 4x squared plus 4x. What you always want to do is reduce anything possible. So I know on the denominator I could take out a common factor of 4x. This could be x plus 1. The numerator I'm going to try and reduce. I'll take out a factor of negative 1 to make it a little easier to see. And I'll see if there's any 4 and negative 3, 12. The factors are 1 and 12, 2 and 6, 3 and 4. Do any of those add to 5? Nope. So there are no factors. This can't be factored. So our answer is just this. That's what we have as our final answer, which is okay. Some of them you will be able to factor and you can reduce. The last thing I need to write is my NPVs. So the NPVs for this one, I can't have x is equal to 0 because of that. And I can't have x is equal to negative 1 because of that. When I look back, I'm going to see if there was any other denominators. It was just these two as well back here. Sometimes there's going to be denominators that you got rid of, so you have to check back to find any more NPVs. And so now we're done. So in all these questions, you're going to multiply to make them have a common denominator. The first thing really you're going to do though is reduce, and we're going to see that when we do this question. If you can reduce anything, you can try and do it. Then you add the numerators together on the top. That's what we did over here. Then you're going to try and simplify if you can, which is what we tried to do over here. This one didn't have any simplification. Now we're going to do this one. It looks complicated, but if you take it one piece at a time, this would be a lot of marks on a test that you can get. I see right away a lot of exponents, so I'm going to deal with those exponents and factor. When we factor, we might find things we can reduce out, and it'll be a lot easier to work with. Because these two look like they're close to each other with common denominators, but they're not. So let's factor. So as I've said before, if you're having issues doing this factoring stuff, like trying to figure out how to get that from that, you need to go back and do some practice factoring because it's really important for this unit. But so once I got all these terms, now what I'm going to do is I'm going to cancel out anything within one numerator, okay, within one quotient right there. So I have x plus 1, those cancel out. These cancel out, and those canceled out. So because I did it like this way, because I factored, it became a lot easier to see. Now I'm going to rewrite this so it's a little nicer and easier to see. So now I realize that none of these have a common factor or a common denominator. They're not the same. So I'm going to multiply each one by each other to make them all the same. The other way you could do it is you could just focus on 2 at a time and then find out what those become and then do these 2 to have the same common denominator as well. Both ways work. I like doing them all at once, so I only have to do my job once. So I'm going to multiply. I know this has to get multiplied by x and x plus 1 so that it'll be all the same. This one has to be multiplied by x minus 1 and x plus 1. And this one has to be multiplied by x and x minus 1. The idea is I'm multiplying by that, so the numerator and the denominator get multiplied, but it's really just equal to 1. It's kind of weird to write that out, so I'm not going to draw it, but I'm going to write what the result is going to be. Let's do a different color. All right, I wrote all my multiplication. Now you'll notice that the denominators are all the same, so I can actually put these all together. I'm going to put them together, and in the same step, I'm going to start doing distributive property and stuff like that to try and figure out what the final term will be. I'm actually going to do it all at once so you can actually see what it is. So this becomes... That was the first one. The second one becomes... I did this one in 2 steps because I did this part fully. I did all the expansion, and then I'm going to do the expansion again in another step. The denominator now is going to be all over x plus 1, x minus 1, because that's what the denominator was here, the common denominator. So now I'm just going to flip this out. I'm going to erase this and write what the final form is. It's, Right, so I have that all written out. The other thing to be careful of is that because there's a minus here in front of this, the minus gets distributed to all the terms inside. So this will change, and I'm going to write it nicer. Okay, now I'm going to collect all the like terms in this giant numerator. When I finally do, we can go through it, but it's like I got x cubed, cubed, cubed. That ends up just giving me x cubed. I got squared, squared, squared. That ends up giving me just 3x squared. I got x, x, x. So that ends up giving me 4x, and the final one 2, and that's it, just a 2, so minus 2. The denominator is still the same thing. What I would have said is if this was a trinomial, you could factor it and maybe reduce, but because it's like 4 terms, you're not going to do anything with it. This ends up being the final answer. Okay? The last thing I have to do that I did not do yet is write my NPVs. What x cannot equal. So if we just look at this part right here, we can see some of them. I know it's 0, I know it's -1, I know it's +1. But if I look back at that original question right here, I also see that let's do blue. Right here, there was also that 4. The other ones I already got covered. They are all covered already down here. So I also have to add to my list, x cannot equal to 4. Because that's what it was at the top, up in this one right there. So now, that's my final answer. That giant reduced thing with these NPVs. Again, this is probably more complex than the type of question you'll have to deal with, but it has all the basic skills that you need to do. Knowing that you need to factor, knowing that you need to apply a negative to all the terms inside, and knowing that you need to get a common denominator so that you can add terms together and make them out of 1 bracket instead of out of 3 like here. And that's it.